Welcome to video 5 on the creation of a model railway. Before we start solving the table, we like to make 100% sure that the layout is going to be fun and the trains drive well without hiccups or blind spots. Therefore, in the previous video we had a 3D simulation in EEP, and in this video we are going to have the layout in the intended automation program TrainController. This is the intended layout, and this is that same layout but now drawn in TrainController. This TrainController is a Windows program intended for digital model railway automation, and it works in fact more or less similar as a real railway by virtue of block control. So what we need to do is figure out what would be a logical division of the layout in blocks. Well, this is a bit zoomed in station Twinwoods, and well, it seems logical to have all the tracks of the station become a block. On these two tracks, the first two tracks, we drive east. So what we do is we create a signal here at the end of the block, and we have two sensors here at the start of the block. What type of sensors, that can differ, that's a whole different question. We are going to use reed switches and a little magnet under the trains, but most people tend to use current detection. So we now have two blocks defined. Well, the tracks 3 and 4 are running the other way, and then the industry tracks are running both ways. So this would be the way to split that station up into blocks. Then we are going to leave the station and drive here on a track before we enter a whole lot of turnouts. So yeah, that also is going to be a block. Here is the sensor that tells the program we entered that block, and here is this signal just before the turnouts, because there could be traffic crossing, so we need to be able to stop over here. Driving the other way around, counterclockwise, here we have the sensor that we entered this block, and just before the station we can stop. We have to, because if both tracks are occupied, yeah, apparently we have to wait. And then we have the outer track, which is two direction. So we have here a sensor for the clockwise traffic, and the signal is over here, and opposite direction here is the sensor for the counterclockwise direction, and then just before the station we have the signal. And this is how you try to figure out what would be logical, and then in the end this is the block structure for the entire layout. And we find these blocks that we just discussed here with these red arrows. Well, let's have a closer look at, for instance, this Twinwoods 1 block. What is the definition of a block? Here we see the general tab, and of course, we can give the block a name. We can also tell the program what the maximum speed of the traffic in this block should be. It is a station, so we like to have a moderate speed of, say, 40 there. And we can tell what the direction of travel is. And then we also see this block editor tab. And if we have a look in there we see the sensor. Yeah, that you don't see the sensor, but this pink thing means that there is a sensor. And that sensor, if it is triggered, this red triangle depicts the stop position of the train, and we defined it to be 150 centimeters from the sensor. And this yellow marker that tells that the train is going to drive on first for 110 centimeters, and then it will have a braking ramp of 40 centimeters. These numbers, they of course have to change per block. They depend on the length of the block, and they depend on where you want the train to stop. Yeah, at the spot where you have placed that signal. But this is the fun of TrainController. It's very versatile if you change these numbers and if you have calibrated the speeds of your trains. Then this always is quite accurate. Let's have a look at the sensor itself. So this pink thing is the sensor. That has properties also. In our case, we use a LocoNet for the data protocol. So it has a module number and a pin number, and that's how you define a sensor. And now the computer, the PC and the TrainController program will know when a train has entered this block. Okay, this was easy. That was a one direction block, but how about this block mid one? That is a two direction block. If we look into that, we have given it a name again. It is a block where the maximum speed is higher. It's just normal traffic. It's a block that can be used in both directions. And going to the block editor, we now see, we defined it ourselves, we have edited this ourselves, that we now have two sensors. At both ends of the block we have a sensor, and every sensor has again a stop marker and a brake marker, and the distances, we have simply measured it. We already knew that from the SCARM file. The SCARM file exactly tells us how long every block is. So this is how the blocks are defined in TrainController, and once that is done, then we can define the train traffic. This is the dispatcher window, which is where we can specify so-called schedules. A schedule is a trajectory where we can allocate specific trains. Let's do an example. Intercity clockwise. We see here in Station Bedford a green marker on two blocks. Green marker means that is the beginning of this schedule. When the train is allowed to go, it drives clockwise around to Twinwoods, which is a station. So we would like the train to make a scheduled stop here. Let's have a look inside this block, and we can see there is a waiting time specified, in this case 40 seconds, which can of course be any number you like. When that waiting time has passed, the train moves on again and it returns to Bedford. This orange marker says this is the end of the schedule. In Bedford we also gave it a waiting time, again 40 seconds. And if we don't specify anything else, the train will stop here and not move on. What we also did is specify a successor of this schedule. Oh wait, I have to click here. The successor of this schedule, here it is, the successor tab. Here we can specify what the next schedule will be once this schedule has ended. And in this case, we selected that it should repeat its own schedule again. So this train, or these two trains, we allocated two trains to this specific schedule. These two trains will keep driving this schedule over and over again because the successor is the same schedule. Well, let's do another example. For instance, let's have a look at the shuttle trains. We have two shuttle trains. Here we can see those are the Flirt and the Benelux, and they are on a schedule, for instance, from Bletchley to Wellingborough. Bletchley has the green markers, that's where they start. Then they drive via Bedford, and they can use 3 tracks there even. And in those tracks they probably have a scheduled stop, 10 seconds, a short stop. And then they move on to Wellingborough, where they probably have a longer stop, 40 seconds. And once they arrived in Wellingborough, if we have not specified anything, they will stop there, but we want them to go on, so we specified a successor. The successor is Wellingborough to Luton. Let's have a look at Wellingborough to Luton. That's this schedule. So now they have their start at Wellingborough. They drive first to Bedford, where they have a stop. Then they drive through Twinwoods, where they have a stop. And they have 3 tracks available. And then they drive to Luton, where they also will have a scheduled stop. This is how you specify which train is allowed where and in which sequence. Well, enough theory, let's put it to the practice. This is the switch panel where you usually operate the railroad. It can be fully manually operated. I can switch any turnout here on the switch panel and I can drive a train. First of all, I can select which train I want to control with this gauge, and then I can give it a speed, and you see it slowly ramps up and it starts to drive. But we can also fully automatic drive. That's why we created those schedules. And I have made a few switches over here, and we can start the schedule that we just created intercity clockwise. Let me start that schedule, and we see here in the list 2 trains have started. Yeah, that are exactly the 2 trains that we specified in that schedule. And we see already one of them is on the move. Oh, it's moving this way. It has a green signal here, so it's moving. Well, it's not because there is no railroad attached to it, but luckily there is this simulator, and if I press play, then TrainController acts as if a complete railroad is attached to it, which it is not, but this is real good for demonstrate to yourself that your layout is actually going to work. 2 trains are driving, they both have a red and an orange color, but let's start a couple of other trains. We also have schedules for intercity counterclockwise, they are the green ones. And we also saw that shuttle schedule, those are the blue ones. Well, not starting yet, but we can see in the list shuttle is started and another shuttle is started. So we just have to wait until their scheduled wait time is over, or until the blocks ahead are free. Of course, the automatic travel automatically takes care of switching the turnouts, and it takes care of the signals. So a train will not start to drive if the route ahead is not free. Here we see our Benelux, the blue one, is going on the move. Well, let's be bold and also start 5 cargo trains. And well, we see now that every train that we had in the list, 11 trains right now, every train is on the move. It has a schedule, and over here we can see green means it's driving forward, orange means it's driving backward, and we can see here their speeds and if they have a green or a red signal. So what we are going to look for now is if all the trains keep driving, if there are no deadlocks occurring, 2 trains in opposing direction and nobody can move because they need to go to the same block. You don't want that, of course. That's what we are testing right here. And of course we are also testing that all the trains keep moving everywhere. You don't want any dead spots. So it's best not to wait simply 5 minutes, but to simply look at this screen for maybe half an hour or an hour to see that this really is satisfactory automatic traffic and the trains can come everywhere. When you have full automatic, then you want that it keeps driving and that the traffic is varied and that every block gets visited once in a while by a new train. Well, this was it. I have run this simulation for over an hour. I was satisfied with what I saw, and Nico, in whose house the railroad is going to be built, is also satisfied. So this gives us the green light to start working on making the tables, doing the woodwork. We are going to saw the wooden plates that we have in shape, and we did not want to start that sawing before knowing, yes, this is the layout we are going to build. So probably the next video will be about how we are going to put those saw lines on the wooden boards that we have. Maybe see you back there, and in the meantime, have fun.